Hi guys, these are the notes for section 7.2, graphing rational functions. This one's going to be a little bit more extensive because there's a few things we have to talk about. We have to introduce graphing rational functions and then talk about graphing them. So first of all, the parent function of a rational function with a linear numerator and a linear denominator is 1 over x. Okay. The thing you should know is that f of x is the same as y, right? So it doesn't matter which one I give you, it's going to be the same. And rational means fraction, so that your x value or your variable is in the denominator, or there needs to be a variable in the denominator. So let's explore what this graph looks like, because we haven't done a rational function before, so we might not know what the parent function looks like. And so I can plug in -2, -1, 0, 1, and 2, right? So all of the x's, I take them and plug them in, and I'll get points like this, -2, -1/2, right? Which is here, -2, -1/2. This one is equal to -1, so I have -1, -1. This one is 1 divided by 0, and you cannot divide by 0. Which means x cannot equal to 0, and this value is undefined. And the graph is undefined at x cannot equal to 0, where x equals 0. And so there's this asymptote that shows up there. Since we cannot have x equal 0, there's going to be a break in our graph at x equals 0. Sort of like x cannot equal to 0, right? Okay, 1 over 1 is 1, so we have 1, 1. And then we have 2, 1/2. Now, if I continue this pattern and I had x equals 3, it'd be 1/3, right? 1/4, and it gets smaller and smaller for the y values, but y would never equal to 0 because 1 divided by a number is still technically a number, right? And if you guys remember from chapter 6, exponential functions, that means we are going to have an asymptote, which is our horizontal asymptote. At y equals 0. Okay, this one is a vertical asymptote. We never used to need to specify, right? Because we only had one asymptote, but now there are two. Okay, so this value gets smaller and smaller and smaller. Technically it shouldn't touch, but even if it does touch, you know that in theory it doesn't, right? It's just that the picture gets really close. And then let's take 1 and divide by 1/2 to see what really happens in between this. So I'm going to do 1 divided by 0.5, just so I don't have to worry about fractions and parentheses. That gives me 2, which implies that 1 divided by like 0.33333, right, gives me 3. And so this value is going to go up, but also never touch 0, right, because we can't plug in x equals 0. So this reminds me a little bit of an exponential function, but while an exponential function has a y-axis, y-intercept, and crosses through, this one will never cross through. And the other side is going to be exactly the same. Okay? So this shape with the two separate pieces is called a hyperbola. Sort of like parabola, but hyperbola, accent on the per. And notice the graph has two asymptotes. And these are lines that the graph approaches, but never touches or crosses. The vertical asymptote happens when the denominator equals 0, because you cannot divide any number by 0. And the horizontal asymptote happens when x gets infinitely big or infinitely small. I realize that technically I wrote the same thing twice, but all of that is an introduction. And in your notes, the part that you should really highlight is this next section. How do we find the asymptotes? Okay, So reminder, to find the vertical asymptote, we need to find x that makes a denominator equal to 0 because you cannot divide anything by 0, right? So that's what x cannot equal to. So to do this, you're going to set the denominator, which is the bottom of a fraction, denominator equal to 0, and solve for x. So you're trying to find the x value that cannot be true, right? In this case, it's 0. So let's take a look and see how that works out. Before we begin, I do want to make a change to example 1b. So please change this to 6 on top and add a 3 on the bottom. Okay. So all we're going to do is set our denominator, which is x plus 5, equal to 0. Oh, let me do that in blue. Sorry, I'm going to try to color coordinate a little bit better. Now we're saying that that value cannot equal to 0, right? Because we don't want the bottom or the denominator equal to 0. So then we can subtract 5 on both sides. And some of you guys might not need to show that work anymore because you know at this point that we're just going to take x plus 5 and know that it's the opposite sign, which means that we cannot have negative 5. That's our vertical asymptote. Our horizontal asymptote we'll tackle next. Let's take a look at the vertical asymptote here. Okay, and I just want to show you guys what happens if it gets a little bit more complex. We're still doing the denominator cannot equal to 0. Okay. I'm going to add 2 on both sides. So if you wanted to just switch the signs, you could do equals to 2, but then instead of just x, there's a 3x, right? And what we're really showing is this. And then we're going to divide by 3 on both sides. And fractions are fine, right? Like we can graph a fraction vertical asymptote. Because all that means is that in between 0 and 1, there's a vertical asymptote at that point. Okay. So let's go back for horizontal asymptote then. To find the horizontal asymptote, you need to find the value of y as x approaches positive infinity or negative infinity. Because if you take a look at our graph, the asymptote, this value happens as our x's get a lot bigger. It's going to basically touch the asymptote. So if we plug in positive infinity or negative, you will get the value you want. So in order to do this, you're going to plug in x equals infinity, or you can use your calculator and plug in x equals 1 billion, which is a really big number. Please know that there's 9 zeros in 1 billion. You can choose any big number you want. I just suggest 1 billion because we're going to talk about billions of dollars right here. Okay, so we'll do a little bit of notes right here on the side so that you can think about what I'm asking you. So I want you to imagine that you have $1 billion in your bank account. And the stock market drops a tiny bit and you lose $5 or you gain $5. Would you still tell people that you're a billionaire? Right? It doesn't make an impact. If you tell people like, oh, I have $1 billion in my bank account, that $5 gain or loss makes absolutely no difference on your actual net worth, right? And that's because if you take a really big number like $1 billion plus even $100, it really makes no difference at all, right? That $100 doesn't matter. We call it inconsequential because that value is so small compared to my billion that it's just $1 billion. Okay, so that's the first thing I want you to think about. My next question, however, though, is what if I take my $1 billion and I multiply it by 2? Does that 2 matter that we're multiplying by? It does, right? Because now you have double the money and 2 billion is way more than 1 billion. Okay, let's keep going. The next thing you need to think about is if you have $1 billion and you divide it by $1 billion, what do you have? Well, let's think. 5 divided by 5 is 1, 200 divided by 200 is 1, a million divided by a million is 1, and a billion divided by a billion is also 1. Okay, last one, 1 over infinity, or a billion. So if you have 1 pi, let's say, or $1, and you divide it between a billion people, those billion people get nothing. Like, in theory, you get 1 over a billion, right? But let's keep cutting it smaller and smaller until we have an infinite number of people. You're essentially going to end up with 0. Okay? So we're going to use these 4 concepts to help us when we plug in x equals infinity. Okay? So we're going to plug in x equals infinity, and we're going to plug it into our original formula for function. 10 over infinity plus 5 plus 1. Okay? And so we have to follow order of operations. Infinity and 5 are stuck together right now. But 5, infinity or a billion plus 5, that 5 doesn't matter. Which then leads us to 10 over infinity plus 1. And then now we can say that if I have 10 divided by infinity, that's the same as $1 divided by infinity, right? It's still 0. So I have 0 plus 1. And so our final answer is y cannot equal to 1. Okay, and that's our horizontal asymptote. So now we have our 2 asymptotes. And I could put that onto a graph, and then we can move forward and graph. Now, someone asked me, Ms. Trey, well, in that case, could I just circle the fraction and cancel it out? Well, I'm going to show you guys here that that shortcut does not work because sometimes something different happens. Okay, so we don't want to take shortcuts. We're still going to plug in x equals infinity. But this time we have 6 times infinity plus 6 all over 3 times infinity plus, minus 2, sorry. Okay. So I have 6 billion, and I'm adding $6 to it, which doesn't matter. And 3 billion taking away 2 also doesn't matter. Okay. Infinity divided by infinity is 1. So we end up with 6 over 3, which is 2. So y cannot equal to 2. So do you guys see how here, like, this fraction doesn't all disappear, right, versus this? So rather than trying to find that shortcut, you actually have to plug in infinity to see what you get. Okay, so now we're going to put all of this together to graph. Okay, our vertical asymptote, here I'm just going to fill in some notes for each section so that you don't have to keep flipping front and back. We're going to set our denominator equal to 0 and solve for x, for what x cannot equal to. Horizontal asymptote, plug in x equals infinity. Our y-intercept, I don't know if you guys remember this, but we're going to plug in x equals 0, which means for our x-intercepts, we're going to plug in y equals 0. And I'm going to say here and solve for y. Here we're going to and solve for x. Not solve, it should be evaluate. Solving implies we're doing opposite. Okay. Domain is all x values, range is all y's. But if we have an asymptote in the middle, that means x can be any number except that asymptote. And how that looks when you write it is you would write all real numbers except or such that x cannot equal to whatever number you get. Okay. And range is all values except the horizontal asymptote. So that's all real numbers such that y for domain, for range, cannot equal to whatever number. let's see this all put together. Okay, it seems like a lot, and it is a lot of little steps, but not too many difficult steps. So we're going to use this as our reference point. Ready? Vertical asymptote, denominator equal to 0. So I know that's going to be x cannot equal to -1, right? I can change the signs. Well, let's graph it. It's vertical. So in case you wanted to go this way, vertical is always up and down. I like to write my asymptote in to confirm that I'm on the right side. Horizontal asymptote, check here, plug in x equals infinity. So we have y equals 4 over infinity plus 1 plus, oh, I should change this, sorry, otherwise it's going to go off the graph. Please change that to a 1. Okay, so I plugged in x equals infinity. Infinity plus 1 is just unimportant. So I have 4 over infinity plus 1, which is 0 plus 1. So we have y cannot equal to 1. And I know it seems like I have 1 a lot. It just happens to work that way because I have small graphs, but it will change, I promise. So let's sketch our asymptote in. And right away, I know my domain and range because I have these values already, right? Which is what we need. So I'm going to say that x is all real values or real numbers such that x cannot equal to -1. And then range is all real numbers such that y cannot equal to 1 from here. You guys see that? Okay. Well, we have a graph, but we don't have all the information yet. I'm going to skip y-intercept and x-intercept for now. I'll come back to that in a little bit, okay, just because there's a little bit more work than we need to do. But what you need to know is that we need to plug some values in, right, just like the front. But we don't want to plug in any numbers. There's 2 specific numbers that are the easiest that will give you more whole number fractions or numbers. Because if you take a look, the closer you are to the asymptote, the more chance there is of you getting a whole number. If you move far away, it's going to become decimals. So let's say that if our vertical asymptote is x cannot equal to -1, the number you're going to put is 1 number bigger and 1 number smaller. Bigger than the vertical asymptote. And then this one is 1 number smaller. Okay, I'm going to circle this because for some reason students had trouble finding it because I didn't put it up here. So 1 number bigger than -1 is 0, right? So I'm going to the right by 1 number, and then I'm going to skip -1 and go to -2. If I plug in -1, you're just going to get undefined. Okay? So now I need to show my work. I'm going to have 4 over -2 is my x, plus 1 plus 1. That's a 1. And then here I'll have 4 over 0 plus 1 plus 1. Okay, well, order of operations, 0 plus 1 is 1. So that's 4 plus 1 equals 5, which goes up here. And look, that actually happens to be my y-intercept, right? Because I plug in x equals 0. Okay, so I'm going to take this 0, 5 and plot it right there. And all you need on this side is now you're going to get closer and closer to your asymptotes. Okay. X-intercept. Do I want to talk about that now? Maybe. Video's getting a little long. I think I'll save it. So this one, we're going to simplify the bottom of the fraction. So -2 plus 1 is -1. Plus 1 is -4 plus 1 is -3. If you make any mistakes with signs in general, please check every single one of these using your calculator. Because I'm going to go -2. Now here you want to be really careful. Sometimes students start at the red intersection and go -2 down 3. You want to start at black and go -2 down 3. right here. Okay. And then we're going to have an asymptote, like approach the asymptote, but don't touch it. I'll do one more. I'm sorry, this one's slightly different, but the concept is still the same. I think students just sometimes panic when they see different problems. So the problem I want us to do is x, I think plus 2 and x minus 2. Same idea. So we're going to follow. Set denominator equal to 0, plug in x equals to infinity. So x cannot equal to 2. Our horizontal asymptote is infinity plus 2 over infinity minus 2. Neither of the twos matter, right? Because if you have $1 billion in your bank account, no one cares about gaining or losing $2. And then we have infinity over infinity, which cancels out to equal to 1. So y cannot equal to 1. And once again, I'm really sorry. I should have made it a different number, but it is what it is. So here's my vertical. Here's my horizontal. My domain and range I can write right away using these. Okay. Y-intercept, x-intercept we'll cover another time. But my vertical asymptote is x cannot equal to 2, so I need one bigger, one smaller. So this will be 3, and this will be 1. Okay. Which will give us points right here. So we have to decide if it's positive or negative, right, on above or below this horizontal asymptote. So I have, let's see, we're going to plug in 3 2 times. 3 over 3. We're going to add 2 on top and minus 2 on the bottom. 3 plus 2 is 5. 3 minus 2 is 1. So 3 comma 5. Here's my graph. And then I'm going to plug in 1 and 1. 3 over negative 1, which is negative 3. So 1, negative 3 down here. Okay. If you wanted a more accurate graph, you could plug in a second point, and that would give you a much more clear how steep this should be, but I'm not too worried about that this semester. So practice your homework. Let me know if you have any questions.